This is a non-right angled triangle, and we're going to use right angled triangles to develop the cosine rule. So first of all, I've got this labeled non-right angled triangle, and I'm just going to drop a line like that so it meets at right angles here. So now I have two right angled triangles. And I'm going to call this length here x. And I'm going to call this length here, well, all the way is b. So just this bit is going to be b minus x. And then here is the height of the triangle, so I'll label that h. Inside this triangle here, the smaller one, I'm going to make up an equation with Pythagoras, which you're going to start with h squared. Now h squared is equal to the hypotenuse, which is c squared minus x squared. So that's one equation using Pythagoras. I'm going to take the second triangle here, the bigger one, and I'm going to make up another equation. This is a little bit more complicated. So I'm going to start off with h squared. Hypotenuse is a, so it becomes a squared. Then I'm going to take away this side here, which I labeled as b minus x. So I've got to do b minus x squared. Now, a little bit of work means I'm going to have a squared. I'm going to expand this bracket. Remember, we did lots of expansions of quadratics. So it's b squared minus 2bx plus x squared. So that's the expansion. And if we just tidy that up, we get a squared minus b squared minus x squared plus 2bx. Now we've got two equations that both start with h squared, so we're going to make these the same. So I'm going to start with the c minus x. Let's do this in blue, so we've got a different part of the equation. C squared minus x squared is equal to all of this, a squared minus b squared minus x squared plus 2bx. Now, what I can see from that is I can cancel some parts of each side. I can get rid of the minus x squared like that. Just going to rewrite it, and I'm going to make a the subject of the equation. So I've got a squared, and I've got c squared plus b squared. Let's write that in alphabetical order. So it's b squared plus c squared minus 2bx. Now, this x here, I don't really want this in my last equation, so I want to find something to do with this x and replace this x. So if I go back to this triangle here, I can see that cosine A is equal to x divided by c. Cosine A, x divided by c. And if I rearrange that, x equals cos A, actually c cos A. Right, on the next line. So x will be equal to c cos A. I'm going to replace that x with this here, and this gives me the cosine rule for a missing side. I've got b squared plus c squared minus 2b c cos A. And what I can do with this formula here, that gives me the missing side in a triangle, non-right angled triangle. What I'm going to do is I'm going to just develop that a little bit further, and I'm going to rearrange it so it looks like 2bc cos A equal to b squared plus c squared minus a squared. And then if I just leave the cos A here on its own, and I divide both sides by the 2bc, this will be a formula here for the missing angle in a non-right angled triangle. So we've got this blue one here for the missing side, this one for the missing angle.